Welcome back to my beginning TDD series. In the last video we ran through the TDD cycle exactly once to get the feeling how it works, and we will repeat this cycle several times this video to extend our list of T implementation. So the next test I want to write is about the fact that I want to retrieve a previously added item via the index operator of my list of T. And I start again with a simple fact that when I add 42 to an empty list, I can retrieve this very value at the first position of the list. And this forces me to create an index property in my list of T implementation. But as I play devil's advocate, I just return 42 in the get method. Especially the type of this index property is just int, and actually it should be T. So that's again a hint to a very vague test, and I therefore will transform this new test method to a theory. But this time it's even a generic one. xunit.net can resolve these generics for you according to the test data being provided, and I therefore transform the method body to use the three parameters items to be added, index and expected, so that I can force the devil's advocate to write the correct implementation. And indeed, this forces me on the other side to write the correct types in the add method, which didn't use type T as well as the index property. To finish the test, I write another public static field called index test data for add, where I create three values for each of the two test runs. And when I execute the tests, they fail, and I have to extend the add method by creating an internal array where I store the items so that I can retrieve them later in the index property. The array is initialized with a size of 4 in the constructor. And when I now execute my tests, this leads to another error, but this time on the test method that I wrote in the last video. And this is because one of the test runs actually tries to add 7 items to the lists, and obviously this will fail if my internal array has just 4 slots. I therefore change the initial capacity to 8. And that's it for this cycle. I commit my changes to the repository and start my next test, and this one is based on the flaw I just mentioned, that I increased the initial size to 8 to get a former test that didn't pass to actually go green. I state that the internal array must be resized, that is exchanged when its limits are exceeded. And therefore I want the test target to have a constructor where I can specify the initial capacity of the internal array. Afterwards I create a loop that adds exactly as much items to the list, so that with the last one the capacity is exceeded. And then I ensure that the count of the items is actually 5. I create the corresponding constructor so that my tests can compile. I then realize that I could jog around as devil's advocate if I do not ensure that the actual capacity is 4 after I called the list of T's constructor. And that's why I add an assert statement in the arrange phase of the test that verifies that the capacity is correct. Please do not regard this statement as an assertion, but rather as an assumption, a precondition that must be met so that the test can continue. This might seem like an error, as asserts should only be in the assert phase, but if you use it as an assumption to clarify the test, you should really place assert statements in the arrange phase or even in the act phase if you see fit. I also exchanged the statement in the assert phase so that it now says that the capacity should be larger than the capacity before. And now I think that this test is much more saying what it does in the method body as the test was structured before. So now I create the capacity property in my implementation, and I just throw a not implemented exception here to let the error messages that occur when I execute the tests guide my implementation. And here you can see that I try to use minimal changes in the production code to produce new exceptions in the test runs, or even make all test greens. This is a common technique that you just make minimal changes to produce new messages, and according to these messages you do the next minimal change. This way you can ensure that you play devil's advocate correctly. In the end, it doesn't matter. I'm forced to create the correct implementation that uses the length of the internal array as the capacity value, which in turn results in the enlarge array method that exchanges the internal array with a new one that has twice the size. And when I'm finished, I actually do not want to refactor anything, and I therefore commit my changes to the repository and I start the next test. This test states that the constructor that I introduced in the last cycle should throw an exception when the initial capacity value is less than 2. I switch to a theory before the first test run so that the devil's advocate has less options to deliver a wrong implementation that still satisfies my tests. I use the assert throws method to verify that the lambda I passed as a parameter does not throw an argument exception in this case. Inside this lambda I create a new instance of the test target, specifying an invalid value for the initial capacity. And this initial value is passed in as a parameter, and here I use the inline data attribute to pass in invalid values 1, 0 and -42. And I can do this because the int type has literals in C# that just can specify 2 attributes. If I use more complex data in test methods, then these complex data types that I usually wrote myself have no literal representation, and therefore this is not possible, or in these cases it's not possible to use the inline data attribute. Yeah, afterwards I create a guard clause in the parameterized constructor that throws the necessary exception. My test turns green, and as I do not want to refactor any code, I commit my changes again to the repository. The last cycle that I want to show you in this video concerns the feature of iterating through the test target with a for each loop. Again, I created a new theory where I add all items of the parameter array to the test target and then state that if I run through it using a for each loop, all elements are equal to the items of the parameter array at the corresponding index. In for each test data, I create values for 2 test runs. After the tests failed, I'm forced to create an enumerator that gets a reference to the internal array and the number of elements it should run through using constructor injection. As this is a private class nested inside the list of T class scope, I cannot write test for it. And I wouldn't advise you to test private APIs in your projects. You could decide to make the array enumerator public, but I did this deliberately here to show you that you wouldn't test private APIs, just the public ones. After I finished my enumerator implementation, I realized that I had a failure in my test code. I did not update the index variable properly. It's important to let each test fail at least one time to discover these careless mistakes. And as IEnumerable of t derives from the non-generic IEnumerable interface, I immediately write another test that does the same thing as the previous one, but with the test target casted to IEnumerable. Again, I let this test fail one time to ensure that it actually does what it's supposed to do. Afterwards, I commit my changes to the repository, as I do not think that I should refactor any of this code at the moment, although there is a code duplication in the last two test methods, but we'll solve that later. And this is it for this video. You saw how you can gradually implement new features to a class by repeating the TDD cycle over and over. You also saw how existing tests provide the ability to find regressions. Think of the first test that failed when I introduced the internal array to fulfill my second test. This immediate feedback of your automated tests provides the safety net so that you can be confident about the code you've written. I hope you've enjoyed watching this video, and I hope to see you again in the next one. See you soon.